Okay, so here we have the question, sum of subarray minimums. So this question talks about uh, given an array of integers, uh, find the sum of like minimum like of the b ranges. For example, let's get this thing easy. So for example, we have the array 3 1 2 4. What are going to be the sub arrays of it? It's going to be 3, then it's going to be 3 1, then it's going to be 3 1 2. Here we have them 3 3 1 3 1 2, then 3 1 4, 3 1 2 4. Yeah, so these are going to be the sub arrays for 3, and then for 1 we'll have 1 1 2 1 2 4. So basically they have to be contiguous, like, yeah, you know, in continuation, no skipping in between, or no, or like not picking elements from between. So yeah, so the thing is that, for example, if I talk about 3, then talk about 3 1, then 3 1 2, then 3 1 4, we need to give the sum of subarray minimums. So in 3 3 1 3 1 2 3 1 4, we'll have 1 3 times as the minimum most element in the subarrays. For 3, 3 is going to be the minimum. So yeah, for 1 1 is going to be the minimum, for 2 2 is going to be the minimum, and for 4 the same as well. But with 3 1, 1 is going to be the minimum, with 1 2, 1 is going to be the minimum. So the question here talks about that you have to give the sum of all the minimums from the all subarrays of the particular given array. How to do that? So basic brute force can be, which I don't think so will be applicable here. The basic brute force would be to do what? To make sure that you're gonna have two for loops in it. All right, you're gonna be like, I start at 3, both the pointers I and j, both pointers are gonna be at 3, and then what's gonna happen is that, all right, starting at 3, I move j ahead, so I'll compare 3 or 1, then I'll get 1, cool. Then I'll move j ahead again, then I'll be like 3 or 2, it's gonna be like 2. Then I'll move j ahead again, it's gonna be 3 or 4, it's gonna be 4. So what did I get by this? I talked like I talked about, you know let's write the brute force. Let's write the brute force. All right, we need to make sure in the brute force that we don't mess it up. How? The thing is that to find out the minimums in the brute force solution, what is required is that you need to compare both the elements, you know but you need to also make sure that you are constantly updating as well. Why do I say that? If you're gonna compare 3 and 1, you're gonna get minimum as 1, but if you're gonna compare 3 and 2, you're gonna get 2 as the minimum. But for this whole 3 1, this whole sub array, which starts with 3 3 3 1 3 1 2 3 1 2 4, 1 is the only minimum. So we'll initialize the initial minimum as the number itself, and then we'll compare this number with this, yeah, while updating the initial minimum. So that means now when we compare 1 and 2, it's gonna say the same. So that is what we are gonna get out of it. So that has to be taken care of, right? Like if I write the brute force, I'll take the length. I'll have a for loop. I'll start from 0, and then I'll have it again. Cool. Now what I need to do is I need to compare. But here if I'll compare like, if I'll compare I with j, I is gonna stay at 3, but j is gonna go at 3, then 1, then 2, then 4. What's gonna happen is that at all terms, at all iteration, I will be comparing every element with 3, but that is not the thing that we need to do. Because comparing 3 with 2, I'll get 2 as the minimum, but 1 is the minimum in that subarray. So here I'll initialize. I'll say int minimum. I'll be like array I. That's it. I'll be like the minimum is arrays I. Yeah. The minimum is arrays I. Cool. So now when you do this, minimum equals to math dot minimum, and then we're going to put in minimum comma j. So now we are comparing. Now we are actually comparing. That's the comparisons are now gonna happen. Yeah. Now I'm comparing that what's the minimum gonna be like, and then I'm gonna say that for each time you get a minimum, you'll get sum as 0, and then what's gonna happen is that alright, you're gonna get sum as 0, and then you're gonna be like, whenever I'm gonna get a minimum, whenever I'll encounter a minimum, I'll be like, add that into the sum. Yeah, cool. I'll do that. I'll return the sum. Wrong answer. 21, 17. Oops. Yep. So I don't think this is gonna get accepted. It's gonna give time limit exceeded or something, because the constraints are very big. Oh, it's gonna give wrong answer. Oh, they asked for the modulo. We can have this as long. We can have this as long. Yeah. We can remove this. Yeah. I'm still not sure because time limit has to get exceeded. I mean, if I'm modding, then I don't know about that, but yeah, it had to. That means it's not a good solution. Yeah, that means this is not a good solution. This is O of n square, and time limit is gonna get exceeded. So we'll have to optimize it. So what's gonna happen while I optimize it? Let's remove this. That's it. So what's gonna happen when I optimize it? The optimal solution now is gonna be like using stacks. Why? So the basic thought process that I have, heard about, and it's very true, is for using, like, when is the intuition that you get that you have to use stacks? That is when you are seeing in a question that you have to store something, you know, you have to store something, and you have to optimize as well. Yeah, that is the moment you're gonna get it as stacks. For the moment, if I'll talk about that, why do I say that? In previous question we saw that our time complexity was O of n square. We are using two for loops, like nested for loops. So yeah, and our space complexity was O of 1 because we didn't create any extra space. In stacks, what's going to happen is we'll be having the time complexity of O of n, and yeah, but we will be creating extra space, so that's going to be O of n as well. But that will be an optimized solution. So how to proceed with it? Yeah, how do we proceed with it? So the way we are going to proceed with it is we will now understand a pattern that's been following. Yeah, so the pattern that is being followed is that for every element, yeah, suppose 1 is going to be minimum if we take any element on the left of it and have a subarray. 1 is gonna get included in that as well, and from 1 every subarray 1 is gonna get included as well. It's gonna be minimum there as well. So the thing is that we need to figure out that at what place 1 is not the minimum, and till what place 1 is not the minimum. What do I mean by that? We need to figure out that are there any numbers on the left hand side of the array with respect to 1 that are less than 1, and are there any numbers on the right hand side of the array with respect to 1 that are less than 1. If they are, we'll remove them. Why do we remove them? That's the question. We remove them because then they will be the minimum ones, but we are not talking about them. We're talking about 1 at the moment. We'll do same with 3. We'll do same with 2. The moment we find the next smaller element and the previous smaller element's index, we'll make sure to first of all not include them. We'll remove them, and then what we are going to do is we are going to find the indexes. That's what it's all about. We'll find indexes that, alright, on the left hand side of 1 we have 3, that's index 0. 1 is at index 1. 4 is at index 3. Yeah, 4 is at index 3. What's there for us to do? We didn't find any index on the right hand side of 1 that's less than 1, and on the left hand side of 1 that's less than 1. That means for 1 we'll have the next smaller element's index as minus, we'll have that as -1, and for 1 on the next smaller element, previous smaller element is going to be -1. The next smaller element can be the length 4. Yeah, the length 4, as there exists no smaller element. So what's going to happen with that is initially 1 is at index what? 1 minus 1 minus -1 is going to get 2, and so the left part I know it's going to be 2. What's the right part going to be? 1 is at index 1, here it's going to be at 4. 3. 4 minus 1, that's 3. Index 4 minus index 1, not the element but the index, it's going to be 3. So here I have 2, here I have 3, on the left hand side I have 2, on the right hand side I have 3. What does it mean? It means that for any subarray from the left hand side, 1 is gonna be minimum when the starting point is on the left hand side, of course, but twice. I'll repeat, 1 is gonna be minimum whenever we are going to start from 2 points on the left hand side of 1. Suppose we start the subarray formation from the index 0, that is element 3. 1 is going to be minimum in that, right? Suppose we started from 1. 1 is again going to be minimum in that. And what does 3 on the right hand side represent? 3 on the right hand side represents that the subarrays that are gonna be having 1 as the minimum are gonna end in 3 ways. It can end at 1 itself, it can end at 2 as well, and it can end at 4 as well. For example, as I said, it can start from 2 places. It can start from 3, 3, 1. It can start from 3 and it can end at 1, 2 or 4, 3 places. It can be 3, 1, it can be 3, 2, it can be 3, 4 till 4, like 3, 1, 3, 1, 2, 3, 1, 4. And also it can start from 1, then it can be 1, then it can be 1, 2, then it can be 1, 2, 4. That means 1 is gonna be the minimum in 6 subarrays, I would say, right? What does it mean? It means that if 1 is minimum in 6 subarrays, that means we'll have to add 1 6 times. That is basic multiplication. We'll have to do 1 into 6. That gives us 6, right? And 1 here, it's gonna be like 1, 2, 3, 4, 5, 6. So that was kind of a long explanation, I would say, but I had to get I had to wrap my head around it because it was kind of difficult for me to understand at first as well. So we are 17 minutes in the video, so brute force was, I guess, done pretty quickly. So let's do one thing. Let's start solving this question. Yeah. So what did we talk about? Previous smaller element, next smaller element. Let's write a code for them. I'm gonna return the arrays because I need previous smaller and next smaller for every single element. Of course, I'm gonna say previous. I'm gonna create a function that is gonna be having a return type of an array of integer type. I'll name it as PSE, and then let's do PSI. Why do I do that? Because I'm returning the index, because that's what I care about. How many places before and how many places after. Yeah, I'll multiply them. On the left it was 2, on the right it was 3, so 2 into 3. Yeah, those two index places can start and end at 3 places. So one starts, it ends at 3 places. The other one starts, is also end at 3 places. So how many total ways they were covered? 6. Yeah. And what's the value gonna be? Into the value of the integer that we're trying to find it for. So what do I need as an input? I'll just need the nums, and then now what I'm gonna do is I'm gonna be like for I'm finding previous smaller index, so I'll start from the start. Yeah, cool. I'll say I'm gonna find previous smaller element, so yeah, I'll be like while I need a stack as well. New stack while it's not empty. So when do we have to pop when we are trying to find the next smaller element? I put in 3. Yeah. If I had 3, 2, 1, suppose for example, if I had 3 in this stack, if I encounter 2 and I find out that the element that I'm gonna put in, it's gonna be, lesser than the one present, I'll remove the one that's present because I don't need that then, of course. So I'll be like, if nums I that I'm gonna put, if that is lesser or equal to oh, by the way, one edge case that I just remembered, because yeah, the thing is, with this lesser and equal, what we need to make sure is that if we're covering 1 here, we don't have to cover it here. Make sense? Why do I say that? Suppose the array is like 1 comma 1. If the array is like 1 comma 1, then I'll be considering 1 twice, which I don't have to. So I have to make sure that either I'd consider it in previous smaller or next smaller. I don't have to do it for both of them. Suppose the test case was gonna have a wait, I'll reload this so I can put in that test case as well. Yeah. So for this test case, previous smaller, it's gonna have 1 as well in it. Of course it's gonna have, because I'll be like mentioning if not equal, like of course the issue that we're gonna face is that it's gonna have previous smaller, it's gonna be -1, the next smaller it's gonna be the length. For this as well, previous smaller it's gonna be -1, the next smaller it's gonna be n. So here in this case, it was not able to cover anything, but we need to make it cover once for obvious reasons, because the question demands us to do that, because the subarray are gonna be 1, 1 comma 1, right? That's gonna be the subarray. And so when we have subarrays, it's gonna be 1, then it's gonna be 1 comma 1, then it's gonna be 1 again. So when if 1 is gonna come again, we need to make sure that when this comes again, then we need to make sure that so when it's gonna come again, we need to make sure that we form it. So if it's gonna be a -1 and if it's gonna be n right here, that's 2. So -1 into 2, that's gonna be, no, my bad. I minus -1, it's gonna be 2. Then 2 minus 0, it's gonna be 2. So it's gonna get 2 into 2, that's gonna be 4. But the answer is 3 actually. I mean, what do I mean by that is that it's gonna be like 1 comma 1, and the answer cannot be 4, right? Let me explain that once again. It's gonna be -1, it's gonna be 2. I minus 1, it's gonna be 2. 1, 0 minus, no, it's gonna be 1, my bad. I'm so sorry about that. It's gonna be 1 into 2, it's gonna be 2. Yeah, it's gonna be 2. Yeah, and same for this as well. It's gonna be 2. Yeah, 2 into 1, 2. 2 into 1, 2. We add it, we get 4. 1 comma 1 and 1. The actual answer has to be, like 3, because we're gonna get 3 subarrays. Subarrays can be 3 only: 1 comma 1 and 1. So in 3 subarrays, the minimum element is 1. So 1 into 3 has to be the answer, 3. But we are getting 4, so we need to make sure that we consider this one, but we don't consider it like We don't. The equal to thing is doing what? It's popping the same element as well. So we need to stop it at one instance, either for previous or for the next. So yeah, it won't pop it when the answer is gonna be 1, not -1, which is gonna be good for us. So while the stack is empty and it's greater than nums st dot peak, yeah, nums st dot peak, what are we gonna do? We'll do pop. Let's write the code a little fast. Let's see. Yeah, if we start from the last, we had 4. We have 4 in the stack. Now we add 2. We say, is it empty? And if nums I less than peak element, we'll pop it. Here we go. Yeah, if there was 3 in place of 1, then 2 would have taken the place. 2. So yeah, I guess we have made them. Now we can say m plus I equals plus I nums. Yeah. And then we're gonna say that for each element, what we're gonna do is we're gonna find out int left equals I minus I is I, and int right is gonna be minus I n. That's right. And after finding right, what are we gonna do? We're gonna say that sum equals sum plus left into right into 1L left into right into 1 and then to the nums I. Yeah, we'll have a mod for it. Yeah, and then we'll have a mod for it. Cool. Yeah, where returns. So oh my goodness, it was nice. Okay, let's refactor it. I can't change everything about it. Control F. Find nums. Replace it with array. Replace all. Thank you. Oh, my bad. We need to hard code it. Wrong answer. Wrong answer. Why? Let's figure out why. How come it's 46 wherein it has to be just 17? It's still 4. Where do we have the issue? Because the answer is not coming as expected. It's way left and right. I don't know. It's coming way more than it should. So what's happening? We have the arrays, we have the index left and right. What's missing? What is missing? Oh, I understood what's missing. That is the how do I and why? I mean, why? Seriously? Why? Yeah. And see, the one I was talking about here in NSI, I didn't pop the equal one. but here I did pop the equal one, you know. But here also, if I haven't popped the equal one, everything would have been fine except for this. Yeah, see. And if I would have kept both, is it less than, yeah, if I would have still, if it would have also given the wrong answer then. It gives 4, and when I removed both, I guess it should be giving as 2. Yeah. So we need to keep at least one to make these type of edge cases work. Yeah. And yeah, that's the question. O of n is the time complexity, and I mean, we can say, if we are going in depth, we had a stack and an array created, so O of 2n, stack and the array also O of 4n, so we created, so it's O of 4n, constants get ignored, so yeah, still it's O of 4n, and yeah, that's space complexity. Time complexity is 1 for loop, 2 for loop, 3 for loop, O of 3n. So yeah, time complexity is O of 3n, wherein space complexity is O of 4n.